Hey guys, welcome to another devish workshop, first hosted by me. It's my first one. Super excited about this talk because it touches on very important details that are not really mentioned on a lot of articles, out there. Uh, this is some unique stuff, and we are super glad to hear this from Allan himself. Um, I'm not really going to say much about him or anything, really. I'm going to let you do that for your own self. You're good at it. And yeah, good luck with that too. We're going to save the last 5 to 10 minutes for Q&A. If you have any burning questions, you can always just like text them on the live stream or on a chat here or even on Slack if you have access to that. Otherwise, take it away, man.
Hi, everyone. My name is Allan Ibutiti. I have been a part of the Devish community from the start. I think I was originally part of, I was in Andela in the fellowship, a little further back than Mark and Jojo here. Then, yeah, picks up a couple of things since then. Just share my screen. I can start my presentation here. Oops, can you see my screen?
Yep.
All right, cool. Yeah, sure. So today I'm going to be talking about performance optimization 101, but this specifically from the direction of putting the application itself in the context of the business, not just for the sake of it. So it's just going to be more of practical tips plus how I think about it and how I go about it. So a little bit about myself. I'm a software engineer at Wazi. Wazi is an online therapy platform. It's completely anonymous. We have vetted therapists who we trust and are good at what they do. I just joined them about a month and a half ago. A month and a bit of change. So I'm part of, I think, they're a PHP shop, but that's something you have been writing Django for about 5 years now. So these are some of the things I've picked up along the way. I'm an indie hacker at heart, and I am building my own application, Get Hasibu. I don't think the landing page is up, but then there's a Twitter by the same Get Hasibu, and you can always find me on Twitter. I'm pretty active over there. All right, so let's start. Here's what we're going to go through. We'll talk about the philosophy behind it, look at our demo project I've prepared for us here, look at some of the tools and strategies, and at the end of it all, we'll go through, we'll have a Q&A. All right, so I'll get started. So I wanted to start here because all the tutorials and documentation that talk about performance, they rarely put it in the context of a team or a business. And I think it's really important to do that because you can end up, there's always something to optimize. There's always something to improve. You can always gain those few milliseconds, but then that's not why you should be optimizing your performance. And so I think the first thing to think about, to always have at the back of your mind, is that the customers are more important than your tech. So this, especially in engineering, we tend to forget this. We build stuff that a lot of times, customers don't care about. The end user has no idea that you have, I don't know, 5 layers of caching with instantaneous invalidation. They don't care. They just want to open your app and do whatever it is that they do with it. And at the same time, it's looking at your customers' needs. For instance, if they run a specific operation 10 times a day, for instance, if that operation takes half a minute, that's a problem. If it takes 2 seconds, I don't think that's too big of an issue. And so you always have to keep this in mind. There's no figure for what a good response time should be. There's no amount of resources you should be using for a certain number of customer load. There's no such thing. It all depends on what your business needs, what your team needs, what your customers need. And so, yeah, so the customers are always more important than your tech. Second thing to keep in mind is that servers are cheap. Servers are really, really, really cheap. So I should put an asterisk there, but they're a lot cheaper than your talent and your time. And so you can try to, it's always a trade-off here. You choose between improving the latency by several seconds, which will save you X amount of money on your cloud bill at the end of the month. But if it's going to take you, if what you're going to save from the cloud bill is, say, I'll use an arbitrary figure, it's $100, and your time is worth $100 an hour. If it takes you an hour or even more than that, it's not worth the change. So that's kind of what I mean when I say servers are cheap. Servers, it's very easy to get a new server. It's very difficult to hire a new engineer. It's very easy to make servers bigger. You can't magically improve the productivity of a single engineer. And so, yeah, always keep this in mind. Servers are cheap. So next thing is simple is better than complex is better than complicated. And I think this is, if you look at the Python manifesto, this is one of them. And as I go through this talk, the strategies I use here will start at the left and go towards the right. And simple, how I think about it is, how is your code readable? How is the code maintainable? Because some of the strategies here will involve increasing, your surface area. So you can have, you can add on new databases, you can replicate your DB, you can add caching, which all of these are just extra things you're adding onto your application. You're increasing the complexity and actually making it even more complicated because there are more than one points of failure here, and becomes more and more difficult to maintain. And so when we start out on the left and gradually move to the right. Right. Then next thing is use the right tool. I think when we all learn to program, you start with your language. I started with Python, and essentially I did everything in Python. So there are certain things that Python is good at, and there are things that it is not. And so we are talking about Django here. Django is essentially it's the intermediary between your data and your storage and your client. So it should be just that. It should be an intermediary. It should be the traffic cop that tells data go here and there and responds to requests. So keep it at that. If you try to make it anything more than it is, that's when you start getting into some of these performance problems here. So Django is very well built, it's very well thought out, and so just use it for the right thing. The documentation is fantastic, gives you cues here and there on what Django should and what Django should not do. There's like, we should really think closely when you start seeing performance issues. Start thinking closely: is your Django application doing something it shouldn't, or is there a better tool to do it? Right. And then, yeah, this is just a thing that I like to always say. Just please don't use signals. They're just really difficult to debug. And going back here, it really increases the complexity of the application for most of the time, not good reasons. So if you ever see yourself reaching for signals, just at the back of your mind, just know that there's something that just don't use them. If when you do need them, you will know, but just don't use signals. Okay. Yeah. So I think we'll just go through our demo project. there's a QR code over there, and here it is on GitHub. So it's basically a warehouse management system. I made this because this is an actual scenario that I have faced in one of my previous jobs, and it looks pretty simple. You have a warehouse. A warehouse has products, but then you can have more than one warehouse. So we have an inventory table here that takes in a warehouse and a product, and inside and each inventory can have a movement. So this is whether it's in, so in is an addition, out is a subtraction, and you can put in details. So maybe it's a sale, maybe it's a stock tick, whatever it is. So it's pretty straightforward here. I'm just going to go into my IDE. Can you see my IDE? You see my?
Yep.
Yeah, cool. All right, so just standard Django application, install the model here. Yeah, so we have a warehouse, just has a name, a location, and a capacity. Capacity is a maximum volume of products that can be stored in it. So it's an integer field. I'll leave this out for now. We have a product. So same name, description, and a volume. So for simplicity, we'll assume the volume is always the same unit. It's not changeable, and shapes don't matter. And so if this is centimeters cubed, it's centimeters cubed. Then we have your inventory, which describes a product's inventory in a specific warehouse. So there's this, ideally, there should only be one row per product per warehouse. Yeah, ideally there should be only one inventory record for each product in each warehouse. So I've enforced that with this unique together constraint here. We the warehouse, it's a foreign key to the warehouse, foreign key to the product, and all of them have backrefs called inventories. Yeah. Then last one is an inventory movement. So we can either have, so I've just used an integer choice, sort of like an enum here. So you either have in or out, and then have the inventory movement table. So describes changes to the inventory in a specific warehouse. So you have F key, foreign key to the inventory table, the movement type, the quantity. So ideally, this should always be positive, because the direction is described by this. So yeah, that's essentially our data model. Let's look at our serializers. Serializers, same thing. I'm using model serializer here just for simplicity. Most of the time I do use them, especially when it's just CRUD stuff, nothing out of the ordinary. So same thing, you have your meta class, will give it the name of the models, each of them, and all the fields that we're going to do here, that we're going to use here. So so over here I have now, let's add in some sort of some complexity here. Let's start with the inventory. So since we're essentially not saving any stock amount here. So what this is a pretty common pattern, because you want to see the movement of inventory, and it's always easy. It's easier to make sure that things are in sync. This way, rather than keeping a field that is always updated with the total inventory. So we get all the movements, all the inventory movements, initiate a field here. We don't need this. So the total is, yeah, nothing. Total plus equals. Yeah, so we are going through each movement, and If the movement type is in, we add it, otherwise we subtract. That's essentially it, and we get the total. Yeah, that gives us the total in, return the total. So for each inventory, so for, say we have a cup, a spoon in warehouse 1, we'll have total of inventory 500. So essentially what it means. And the product here, it's fairly common to want to know the total inventory of the whole thing. So for say you want to know how many spoons you have across all warehouses, same thing, total inventory is summed through all the total inventories here. So the next thing is a warehouse. We have a capacity here. So a product will occupy space. So if we have 10 products of volume 10, you would have a capacity of 100 that's been allocated to this product in this warehouse. So here, occupy capacity, same thing, inventories, get all the inventories down here and get the sum of inventory, the total warehouse inventory times the product volume for each of them to get the occupied capacity. Then our available capacity is just a deduction of capacity minus that. So these are properties, and in Django, how these work, whenever you reference this specific field, you can call it using the dot notation. You don't have to call the function itself. So if I have a warehouse instance, warehouse dot occupied capacity will run this piece of code here and give me the total. So yeah, I know already if you can, there's some apparent issues here, but we'll get to that. Then you have your typical view set. So I'm using a model view set, just pretty standard CRUD. You get CRUD out of the box. I'll leave this out for now. I'll get back to them in a little bit. All right, so seems pretty standard, pretty innocent, but this will have some pretty serious performance issues here. So I'm using SQLite. Don't use SQLite in production. It's not encrypted, but for this purposes, for this purpose, we'll just use SQLite because it's easy to get started. Yeah, so just going to, sorry, let's get rid of that. Yeah, let's get to post one here. I've already seeded the database with, I have a little seeder here that creates, I'm using a scale of 10. So 10 warehouses, 1,000 products. So then relating the products to just making inventory objects here, and then creating 1,000 inventory movements, and I'll distribute them evenly through each of the inventories. So essentially that's our data model here. Right. So cool. From here we can just do a simple request here. You'll notice it takes a pretty long time. Yeah, so this is a warehouse here. Typical, this is Django REST framework best practice. If you go through the tutorial and do something of your own, this is probably what you'll get. Where something here I should have mentioned. On the serializers here, there's nesting. So so we have the inventory movement serializer. This will change our Django objects back and forth from Python objects to JSON to Python objects back and forth. So our inventory serializer here quotes movements and with this is a nested serializer. So whenever we are getting movements, we'll pick up this serializer here. Same thing all the way down to the warehouse. So warehouse inventories will pick up the inventory serializer. Yeah, so looking at the warehouses here, our results. You have your ID name, capacity, your occupied capacity, and your inventories. And so this will have, so product one in warehouse one, this is the total inventory. Sorry, this is a spurious number, but just bear with me here. Movements, here they are. So all of the movements, you get them here. So this is a 1 MB payload that took 3 seconds to load. So yeah, this is typical when you're just starting out. When you're starting out, don't have a lot of data. It's highly unlikely is going to be this much data. I think this is it should be about 10 or 10,000 data points here. But when you're just starting out, this never really is a problem. Let's get rid of our DB here. Migrate. And we do a scale of 1. Just click as 1. Okay, just a sec. Let's just default this to 1 for now. Yeah, let's see the DB scale equals 1, which means we'll have 1 warehouse, and then we'll rerun the query again and see just how it does. Good. Okay, sure. Still a lot of data, but it takes 3.18 seconds. Not really an issue at this point if you don't have that many users. Come to the products again, same thing. It will take a little longer because you have you're picking up the inventory for all of them. Takes 6.2 seconds. There's a 1.2 MB 1.2 MB payload as well. Still pretty high. Invoices, so you have your inventory, same thing. Lots of data, which now, so that's essentially is our little system here. All right, cool. So let's move on to the tools and the strategies. So I think the first thing that all performance problems are either one or both of two things. So either it takes too long to compute or it's too big, or both. So for our case here, we have the first pretty clear. So the first thing you do whenever I approach performance optimization is I need to profile. I need to know exactly what it is that's causing your application to be slow. So there are two options that are pretty good. There's a Django debug toolbar. I prefer Django Silk because it works with DRF, Django REST framework as well, which so in our case here, it's pretty easy to set up. You install it via pip. And then you just set up in your settings.py, put in your Silk here, Silk framework there, and you put it in as a middleware. So I put it as far back as possible to make sure that it profiles all the other middlewares beforehand as well. Then last thing is to add the Silk URLs to it. Just migrate your database and you get a really nice Silk. It essentially profiles for all your endpoints here. So for our warehouses here, like you can clearly see, like it took 2.5 seconds overall. 3.3 seconds was on queries, and it ran 631 queries. If you look at the SQL it's doing, it's essentially just you're going through each and every one of them inventory movements here. all over and over and over and over again. Next one is the factor worst performing one is the products, which gave us took 3.8 seconds. It ran 2,300 queries. So like this is a lot of queries going on. So if I'm just starting out and I want to make this a lot easier, the quickest thing I can do, which now brings us to the first option, which is pagination. So really simple way to do it. Just reduce the amount of data that you're giving back to the in the request, in the response. Here for Django REST framework, it's pretty easy. You get a pagination class. I'm using limit offset here. And coming back to we can clear out our database. Just keep this in mind. We started at 3.8 seconds. Clear it out. Come back, rerun our query here with pagination activated. So you have a count, your next. It took 258 milliseconds and your payload is about 100 kilobytes now. Just one line and you've brought it down from 3.8 seconds to less than 200 milliseconds. So this pagination is great for first reducing the amount, just the amount of data that you're taking back, that you're processing, that you're querying from the database. And second, like even for expensive calculations, if you're running the expensive calculations on a smaller number of rows, that's a win here as well. So first thing, there are several options. The documentation have a good one, have a good rundown on them. So page and limit, these are usually good for when you have finite amount of data. So think of you have transactions or products or whatever, that these are usually pretty good, page number and limit offset. Then there's a cursor pagination. So these ones, they need the database to seek through and find the page number first before returning your data. That when you have a lot of data, this can become a problem. So cursor is what is a fix for this. So if you have something like a Twitter timeline, they use cursors to paginate. So your free time is a bit of I won't get much into this. Just an introduction on how to look at it. So have a look at cursors if you have hundreds of thousands of data points. So that's you should reach out for that. Otherwise, this pagination makes the queries even slower with when you have a lot of data. Right. Next one is serializers. And I alluded to this problem before here, to this solution here. Let's go back to our code. So looking at our, if we look at how we are, sorry. So when we get our warehouse data here, so pick up our warehouse data here, paginated. Yeah. So still really large payloads as much as it's paginated. We only have 10 warehouses. So the reason it's so much is because we are pulling in the inventory and we're pulling in all the inventory movements. So there should be about maybe 500-600 here, 600 movements. So this still ends up being a really, really big object, because we're pulling in data that if you're looking at a warehouse, it's highly unlikely that you will want to, yes, you might want to know what inventory, what products do I have inside my warehouse, but on a request to pull in your warehouse, it's highly unlikely you'd want to know that on this date and time, there were 50 that came in. It's unlikely that you'd want to do that. And so we have, so especially when you're doing a whole list, this is a list endpoint, so you're getting all of them, you're fetching all of them. It might make sense if you want to maybe get one warehouse that you want to get all the inventory movements, but when you're getting all of them, it's highly unlikely you want them. So serializers have related fields. So first thing is, when it comes to related fields, here we are. So inventories here. This is a foreign key. So this is a backref. So warehouses have many inventories. So main equals true. If I leave this out over here, what it will get back on the related fields is just going to be a list of IDs, right? So this is, it defaults to the primary key related fields. But if you wanted to do something else, there are others. So there's a slug related field, the slug related field, there's a integer related field, primary key related field. So all that does is it just, you can, if you were to choose a slug, for instance, you can just say what is the inventory here? Yes, yeah, you can just say the source of it is a quantity, for instance. So I'm just going to leave it as a primary key related field. So we brought down our, I think it was close to an MB to 2.6 kilobytes. It still takes a long time to do. But yeah, we have a much, get back to our profile here, give it a small refresh. Getting warehouses. We're still running a lot of queries. Takes 1.4 seconds, still running 430. We'll get to queries for now, but then we have dropped it down way lower because we are not picking up any of the related inventories and the related inventory movements for those inventories. So we're getting rid of some of that nesting. Brings it to the next point here, nested serializers. And so these, it's great. They're useful. You can get a lot of data in one request, in one round request. But then there's a downside to it. So when you're starting out, usually it's not really a problem. But then when your data grows, you might need to think about how you return your data. So nested serializers here, it's a big issue, probably not useful at all. And so just move this back. What I like doing to the final point of this, there is the get serializer class on your view. Let's get to the view here. Yes. Yeah. So whenever a request comes in, this view class will get it, and one of the, so you can if you don't give it any of these extra methods, if you don't override any of the methods, it will use the serializer class that you give here and the queries that you give it. Pretty standard. So what the get serializer class is pretty useful, because if I see that the action is list, right? For instance here, list is like get all, right? If I see that the action is list, so this request that has come in, it wants all of the warehouses. If I give it back the entire warehouse serializer that we had before here, it gives back a really big object back, close to a megabyte. So I've prepared here a slim serializer. So yeah, you can even get rid of them. So what this does, just gives it the ID name in the city. I think I've seen these a lot. This is a pattern I've seen a lot in a lot of code bases. So the action is list, return the slim serializer without all the extra data. You time goes down to 40 milliseconds. You have less than a kilobyte, and this is usually what you'd want on the list view. And then if you want a detailed view, it can give you the same. You can get the big object now that you want for a single one. So what this does, when the request comes in, a get request to the root of this resource gets you all of them on one. This is called the retrieve route. This is the retrieve route. This is just the Django naming conventions. Yeah, so if you go to the retrieve route, then you get the same one. Yeah, that's it on the serializer. So yeah, and here you can do all sorts of things in this specific get serializer class. So this is really useful when you want to control, use different serializers for different contexts. So yeah, we can change it to the stream warehouse serializer. Yeah, just like that. Yeah, so that's it for the serializers here. Serializers. Let's move on to the next one. Next is the query optimization. So I found that usually this is most performance gains can come from this, because a lot of times issues we try to use Python to do for things that it's not meant to do. One of them is aggregations. So here on my models here, getting back to this point here. So occupied capacity. So let's start even here at the bottom, the simplest of the arithmetic. Here we are querying the database for all the objects. We set up a variable here, and then we end up running the calculations in Python. So this is highly first of all, you have to retrieve all of your data, come back, and then do the arithmetic in Python. That's a DB. The DBs are particularly good at doing arithmetic, doing aggregations. So instead of doing all of this here, we can say do a single query. Here I'm just going to assume that all the inventory movements are like one. Whether it's positive or negative, I'm just going to assume it's the same thing. So the total here is going to be self dot movements dot aggregate. Yes. Yep. There you go. Copilot is fantastic. So you find the total. If we run this again, it essentially got down from, let's just quiz, 432 queries here. Get warehouses, get warehouses one sec, get warehouses. Yeah. So we got down from 430 queries to 2 queries. That's the first part of it. The second part of it is just the database is just really fast at doing this kind of problems. And so right tool for the job. When you're doing aggregations, always think about the warehouse, the database itself. Next one is related objects. So here we have a lot of foreign keys in our up here. So an easier way to, when a request comes in as well, there's this query set object here that we give the view set class. But if we put in this query set is passed on to every other downstream, every other Python object Django or Django REST framework object downstream. So the serializer will get the same query set. It will run, there's validations, we're doing validations, data querying, all that, it will use the same query set over here. And so something that you can do to make this a lot easier. So we do know for the warehouse, when you go down to the warehouse serializer here, we know that we're picking up the inventories here, and the inventory itself, looking at it, the inventory itself has the product because it comes in when you're calculating the inventory, and we still do another query for the inventory movement. So a very easy way to do it here on the view is making sure that we fetch, I've done it here. Is making sure that when you're getting the query set from the very beginning, you prefetch all the related objects that you want. So there are two ways to do it. So there is select prefetch related. This gets you your like your child objects. So inventories are for product is a foreign key to inventories. So this is like you're getting all the reverse relations. So the DB will first run this query, and then use this query to get all the related inventories and movements. I'm using the dunder notation here, which just says when you're getting my products, get the inventories, and when you're at it as well, get the inventory movements as well that are related to these inventories. So if get rid of that, let's come to our products here. It takes 225 milliseconds. It runs 32 queries here. So we can just change this here. Make sure that we are prefetching all the related inventories. Oh yeah, and you can do just to make sure that you don't mess with the internal things like permissions and all that. You can just do query set. You can just call the super call, get the query set, and then you can bring this here and just do the same query set, prefetch related. So this makes sure this just runs the internal Django REST framework stuff. And so permissions, filtering by, okay, so you have companies or whatever, and bringing that here, 134 milliseconds, checking our queries. We brought it down from 32 to 4, all by just single line of code here. So for this, you don't really have to, you can check even the actions as well if you so wish. So sometimes I've come into code bases that have specific work that is done on the create. So we can use this opportunity here. This gets passed on to the serializer here. So if you have special functions or whatever in your serializer that need certain fields from the database, just fetch everything at the query set level from the class and then bring it all the way down. I think yeah. Oh yeah, and then there is the guardrails here. So we went through the get query set, then test guardrails. So what I like to do for myself to make sure that this doesn't happen again, I like to write it on my tests. So we saw here that our products, getting products was running 32 queries. We changed it, it's now running 4 queries. So one of the things that I like doing, especially when it's an endpoint that has a lot of queries, I like to go through it, and once I do performance optimization, I have brought down the number of queries. I put in a guardrail here. I know the number of queries run whenever I get products is 4 queries. So let's get rid of that because I've added pagination. If I run this test, it should work. Oops, 19 queries were executed. Okay. Let's have a look here. Yeah, interesting. Should do 4 queries, but okay, I don't know why, but yeah, but that's if something was to happen further down the line, somebody else would say, come, call it this, let's call it my team. Someone comes and view class, they see this and say, okay, this doesn't make sense. Let me just remove that. And then they try to run the tests again. You'll see like it will catch it and say, this place we had done, it should have 4 queries. Now it's got 22 queries expected. So this is kind of like a guardrail to tell you what's going on here. And then, yeah, here, oh yeah, I know it's taking so many queries because it's also counting silk requests. But yeah, this is, it tells you where those queries are coming from and what they're doing. And this is kind of like a guardrail to make sure that you don't get into regression. Because a lot of times when you're developing locally, you never get to see the amount of load that typically hits the application. So this is kind of like a guardrail to make sure that once you fix it, it's never going to happen again. Right, so I think time is running a little short. So so the next thing is background jobs. There are certain jobs that you can optimize a query, you can optimize and it still takes too long. So this is where I reach for background jobs. So these are long running. So typically for computationally heavy operations, you can push these to the background. There's many solutions for it. Redis and Celery happen to be the most popular. RabbitMQ doesn't work on itself by itself. It has to work with Celery, I think. But yeah, these are some of the solutions that exist for that. They're very well documented and pretty good. Then the last one is caching. I personally love Redis. And as well, I think it's a single line or single config change that really does improve your performance. But then again, going back to this just adds on a bit of complexity to, not even complexity, it makes your code complicated because you have to worry about a new piece of software that you're maintaining, whether it's Redis or whatever, Redis, Memcache, whatever it is. Then you also have to worry about caching validations. You have to keep in mind what endpoints serve well for caching, which ones don't. So it adds on some complexity. But yeah, looking at this toolkit here, starting with the simplest. First thing first, profile your code. Second thing, paginate. Third thing, check what your serializers are returning. Are they nested? Are you pulling in related data that doesn't need to be there? Next thing is optimize your database queries. And once you already do that, make sure you put in a guardrail in your tests to make sure that this doesn't happen again. Yeah, then background jobs. So take out the expensive operation from the main thread, main application worker, put it on a new worker, spin up as many as you wish to cover your background jobs. I think Celery usually gives you a very nice view of how well your jobs are performing, and you can decide whether to add more workers or whatever it is. So yeah, then last thing, which I think more people should do less of, it's usually the first thing that everyone does, caching. Yeah, it's more of a, caching is a great thing. It's fantastic for performance, but then it usually ends up adding in a lot of complexity to your code. Yeah, so we saw our product query, warehouse query come from 632 queries all the way to 2 queries and 9 milliseconds, 2.5 seconds for products. I think we got it from, I think it was much more than that, but yeah, 250. Yeah, so it started out, I think it was 3.5 seconds or something like that, and about 400 queries, brought it down to 4 queries, 1.13 of a second. Yeah, I think that's it. Let me stop sharing. Cool. Yeah, I think I'll open it to Q&A now.
Yeah, thanks, man. I was, man, I haven't touched Django in like 4 years. This was definitely interesting to experience. Thank you a lot. I haven't seen any questions so far. I'm not sure if anyone has any. Also on the call, feel free to just ask. We have about 5 minutes to do this. Nothing on the channel as well.
This should I take it to be a very good thing, or it's either no questions, either I did very well or very poorly.
Perspective.
This is my first workshop as well, so
it is.
Yeah.
Okay, 19 slides, man. Impressive. Well, I'm seeing like 6 likes on YouTube. That's
nice.
Great. That's great.
Cool. This is saying, oh, thank you. Yes, try to make it very practical, because I think a lot of the times, a lot of the tutorials I see on performance are usually just about, oh, look at how fast this is. Look at how I can make this fast. This, if I hear one more time how like Python is slow and you should all use Node or Rust or whatever, I'll lose my mind. It just doesn't exist in isolation. It exists inside the business and the team. Okay. So I wanted to make it very practical. Just so like you don't respond to a mosquito with a hammer. So you start with something very small, both in time-wise and complexity, and then move on to increasing the complexity as you go. Okay, more questions here. Some of the things you can do to optimize tests. That's a good question. So one of tests, in my experience, what makes them run, especially when you use the Python unit test framework itself in Django here, I noticed that fixtures take a very long time to load. So you have to be very intentional about how you make your fixtures. The PyTest patterns that it has, they make it easier. So you can just have, you can I think it's called dependency injection. So you just add it in on your test class. You add in the fixture. You define your fixtures in one place, and only pull in the fixtures you need for that specific test. That I like that pattern because it discourages just bringing in everything, that making one big base test class, and with all the fixtures in the setup method, rather than pulling in the specifics that you need. Yeah, I hope that makes. Oh, and PyTest also comes in with you can parallelize your test runs, so you can do multiple Django instances, multiple databases, and they can run in parallel. So that's the two things you can do. Silk performance monitoring in production. No, we don't use Silk in production. This is because it has its own overhead. You've noticed it has its own database tables. There's a configuration that you can put in there that tells you of that specific request, how much time was spent, how much of the computation, whether time and space, was spent on the profiling that Silk does. You can do a lot more with it. You can profile even single functions or single classes, and it can tell you all the. It will profile the entire call stack, essentially what the Python profiler does, but in a much nicer way. So no, typically you'll start noticing you'll have something like Sentry or I don't know however you collect your logs. Typically, I think I see Gunicon will have, you can add on a field of how long a request takes to execute, and you can set up triggers, whether you're using Datadog or whatever. Just whenever something gets past a certain amount of time, raise a flag, and you can explore that on your local machine using Silk to try to see what's going on. What's the difference between prefetch related and select related? That's a very good question. It's I think just look at the docs for that. So select related is if I want to pick up my parent. So if I'm the inventory table and I want to also select the related warehouse and product. So that it's usually for the parent. Then this is how I like to think of it. Then prefetch related is for the children. And so the reverse of the foreign key relationship. So just have a look at the docs. I make a mistake all the time and end up going back to the docs to make sure I'm using the correct one when it fails. And something else, there are prefetch objects, which are essentially subqueries that they evaluate into SQL subqueries. So those are very, very useful and powerful. I didn't get into search. Yes, that was intentional. So search is a difficult problem. Yes, Robert, I'll share the slides. Search is a very, very specific problem to like your API and your application. So I don't think there's a good way to generalize advice on search. However, I will say if you're filtering and your CSR, and you keep on using filter a specific field in your say maybe using DRF filters or something like that, I would say just look at the fields that you're filtering on a lot and add an index to them. So there's things you can on the model definition, on the field definition is just models.integer field, and then one of the keyword arguments you can give is index equals true. That will give you a significant performance gain. Just know that whenever you add an index, it has a cost, and usually the cost comes at right time. So just keep that in mind. Then pre-caching, preemptive caching. Okay, yeah, you can always do preemptive caching. That's cool. I didn't get into caching as much because I would say like 80% of the applications I've seen in Django don't need caching. You just need to write your database queries pretty well. Then so Django in itself, it does a lot of caching for you. The reason you don't notice is because it's very sensible caching. It never really causes any problems. So if you run a query once, for instance, if you run a query set, if you execute it, the results are cached. So it doesn't need to keep hitting the DB for other things. But yes, caching, like there's the Django cache docs are pretty good. So I'd say look at that, but use it as a last resort. If you need profiling in production, Datadog does a great job. Yes, Robert. I've used Datadog as well. It's cheap when you're starting out, but just keep in mind these log tools get prohibitively expensive as you go. So just careful with your logs. Then for performance optimization of signals. Okay. I really don't like signals. I've used Django for 5 years now, and I have never had a good reason to use signals. If you're writing, and then let me explain. It's not just because I don't like. It's very difficult. So I like to write my code in a way that it's very clear what it's doing, and you don't have to jump through hoops to understand what a function is doing. We can only hold a certain amount of information in our heads, and when you keep jumping from one place to the next, to the next, to the next, it's just a bad developer experience. And at the same time, signals fire so they don't happen inside a transaction, so there's no performance gains on it. They don't some of the things that we put in, things like if you want to control how the save happens, it doesn't call the model save. If you've modified the model save on your model class, so it just hides a lot of those things away, and you end up having to tell somebody, oh, by there is a signal, or you find out for yourself that signals are happening. Where they are useful is when you have reusable apps. So that is a use case that makes sense. That I see it's useful there, and it's appropriate to use there. If you want to modify actions that happen when a model is saved or created or updated or what, they're all the save methods, the updates. There you can add on a little function there that just whenever somebody is reading through, they can see this is happening. This is a side effect of this. Yeah, at least for Datadog. Yes, Datadog YouTube. Yeah, indices. Yeah, great, awesome. So I'll share the slides. I think I'll put it up on the developerISH channel, and I'll also put the slides on the GitHub repo.
Yeah, and we can also tweet it through the developerISH Twitter handle, share it on social medias, everyone to get access to that. But I definitely appreciate you for doing this, seeing all sorts of compliments from everywhere. Honestly, up to 12 likes.
Nice.
That's a lot, man. That's a lot.
Nice.
Otherwise, I think we can close it from here, man. Thanks a lot once more. I'm gonna at least make sure you share those slides on developerISH, and then we'll move it all over the globe. Once more, thank you so much, and this is pretty much it. Thanks, guys.
Thanks, y'all. This was a lot of fun.